Welcome to section 1.3, Writing Expressions. Now, a lot of what this chapter will involve is we'll take an English sentence and work on converting it from English into a mathematical expression. So what we'll have to do first when we're looking at breaking this down is looking at all the different words that we have in English that mean the same thing or mean the same word in a mathematical expression. So if we are looking at our addition sign, you could maybe see add be used, like add 2 and 3. Or you could see that as the sum of 2 and 3, or 2 plus 3, or the total of 2 and 3, or 2 more than 3, or 2 increased by 3. Any of those all mean the same thing as to add. Now, if we are looking at the subtraction sign, what are different words that could mean, like that could be for that? Well, first, somehow I missed having subtract on there, but you might also get the difference of, or 2 less than 3, or 3 minus 2, or 3 decreased by 2. All of those mean the same thing as to subtract. Then we have our good old multiplication. So you might get 2 times 3, the product of 2 and 3, 2 multiplied by 3. Or that of sort of gets put on there, and that relates more with fractions. So let's say we had like 3/4 of 12. Well, 3/4 of 12 would be 3/4 times 12, which is 9. Finally, we also have divide. So you might see 12 divided by 3, the quotient of 12 and 3, 12 or 3 or 12 divided into 3. Or you might see that word per on there in more word type problems. So like if you're working in terms of miles per hour, that happens when you get miles per hour. So you get your miles divided by your hours. So those are all of the different words that we might get that we have to figure out how do we dissect our English sentence to turn it into a mathematical expression. So to start out, let's look at 4 less than the quantity 6 times the number n. Well, that's a lot. So let's break this down just starting out with the beginning. So 4 less than. Well, if you think about it as like 4 less than 10, or even like 4 less than 100. Let's do that just to make it a little bit bigger. 4 less than 100, you know, is the same as 100 minus 4, which is 96. So you can see 4 less than, it actually sort of flips the order of how you would actually write it down. So that just means that we're going to subtract 4 here at the end. Then we go on to the next part. What is 4 less than? Well, it's the quantity 6 times, so it's going to be 6 times a number n. So 6 times n minus 4. And that would be our answer. Let's look at the next one. So we have 3 times, we can start out with 3 times the sum. Well, since we're already mixing multiplication and addition, we just need to make sure that we lump together our sum using parentheses. That way it doesn't accidentally get trumped by order of operations. So we're going to have a sum of 2 things, and those 2 things are 7 and a number y. So we're going to have 7 and the number y. And that would be our answer for this one. Our final one in this case is the difference, and difference again means to subtract. So the difference of 22 and. The word and tells you where you put that subtraction symbol. So 22 and, so that's going to be our minus. The square, so whatever our thing is, it's going to be squared of a number m. So that means it's going to be the number m, or the variable m, and it's going to be squared. And that would be our final answer for this one. Our next question, I'm actually going to draw a picture for. So we have a piece of ribbon that is L feet long that we cut from a piece of ribbon that was originally 8 feet long. So we have our 8 feet for this length of ribbon, And we're going to come through and take our blue scissors, and we're going to chop this up right here to make this length our length L. So what we then have to do is write an expression for the length in feet of the remaining piece. Well, this started as being 8 feet long for this entire length, but now we go and we take back this portion. So it can't be that part, so it's going to be 8 minus that portion, L. And once we get rid of that, all that's left is this little bit left. So this here would be an expression, 8 minus L, for that remaining piece. Now we're getting into the part where I have to start introducing a few vocabulary phrases. First is a verbal model. And a verbal model is when we're working in a real-world scenario and we combine actual words with mathematical symbols. So for example, in this case, it's you and 4 coworkers are working at an ice cream shop and you're trying to divide up the tips at the end of the day. Well, for our verbal model, what we will do is we'll take our tips, our total tips, and we're going to divide that by our number of people, which in this case is you and 4 others, which is a total of 5 people. Now, something you need to watch out for, especially as you're writing your test question, is I want you to create one of these where you have to write the model, like draw the model out and like write it down, but it also needs to be solvable. So that means at some point during your question, you'll also need to tell me how much would be your total tips that you're trying to divide up, or whatever other scenario you come up with as you're writing your test. It just needs, you need to give me enough information that it can be solved to, not just stopping here. So like if I said, we got $100 in tips for the day, then that would be 100 divided by 5, so everyone would get $20 in tips. That would be a scenario that you could try to set up. Our final questions for this section are actually dealing with rates and unit rates. Now, rates are like miles per hour. So you are having a fraction where you're dividing 2 different things. A unit rate is when your denominator, that bottom part of the fraction, simplifies down to 1. So if you're going 60 miles per hour, you're going 60 miles in 1 hour. For this question, we're actually having a car travels 120 miles in 2 hours. So we're going to have 120 miles over 2 hours. Well, what we have to do then is, it actually wants us to find the unit rate in feet per second. So we need to convert from miles to feet and from hours to seconds. Now, the easiest trick with this is start with what you know. How many minutes are in an hour? I don't know how many seconds, but how many minutes? Well, we know that 1 hour has 60 minutes. The other piece of this that you need to pay attention to is the side of the fraction that you write things on. Because since 1 hour and 60 minutes are the same, this fraction that we're multiplying by here is the same as multiplying by 1. And we know that when we multiply by 1, nothing, like it stays the same. Our answer stays the same, but we're just changing units. So the number will change, but the answer will actually still be the same value and speed. But what we need to do is we need to watch the diagonal. So we have 2 hours on the bottom left and now 1 hour on the top right. Because that's across the diagonal, we can cancel our units. So our hours here can cancel with our hours here. Then we can go and convert from our minutes to our seconds, because we also know that 1 minute is equal to 60 seconds. And that will let us cancel our minutes. Last thing is we need to convert from miles to feet. So hopefully you've learned at some point that 1 mile is the same as 5,280 feet. And in that case, your miles will cancel with your miles. So what's left then? Well, we have 120 times 1 times 1 times 5,280 divided by 2 times 60 times 60 times 1. And if we go and multiply this out, as I will on my handy dandy graphing calculator, 120 times 1 times 1 times 5, 280, divided by 2 times 60 times 60. That will leave us with an answer of 88 feet per second. And that would be our unit rate, which is exactly what it asked for, because it's per 1 second. Our last question is saying that you are running, and you run for 2 miles, and then you slow down and you walk at a rate of 0.1 miles per every 100 seconds. And you do that for 20 minutes. Well, let's just convert this into an equation first. So we have 2 miles that we run, and then we are going to walk some further distance that we know is actually 0.1 miles per 100 seconds. And that's going to go on for 20 minutes. So it's just 20 minutes, it's not another rate, so you can actually just do that as over 1. That way you just have fractions that are being multiplied, it just looks a little nicer. And now we either need to convert from seconds to minutes or from minutes to seconds. Well, I'm going to go from minutes to seconds just because that's a little bit easier for my brain to work with. So we'll go across the diagonal. So we'll have 1 minute on the bottom is the same as 60 seconds. And now our minutes will cancel with our minutes. And actually our seconds will cancel with our seconds. So the only label left for this entire portion is that miles. So what's left then is that 0.1 times 20 times 60 all over 100, which comes out to times 20 times 60 divided by 100. That comes out to 1.2. So that means this whole chunk inside the parentheses is equal to 1.2 miles. But we still have to bring down that 2 miles that we walked at the beginning. So we know the total distance that we walked comes out to be 3.2 miles. And that's it. That's all the more there is to it. So hopefully this was helpful. And if you have any questions, make sure you reach out and ask. Thank you so much.